Hi, I just want to develop embedded C program for I2C based ADC, which is PCF8591 with 8051 as a master. So just to develop your program, go with keil microvision, choose the option project and select the option new project and give your project name in a specific folder like whatever you created. So this is my folder name and this is my program project name. This project name doesn't require any extensions. Give your project name and click on save and choose your target device on which microcontroller you are working. And this window allows microcontroller from which manufacturer and what is the series of device. Now I selected Atmel. From this choose AT89C51 and this is a startup code warning. Click on no. And I already developed a program. I will explain very clearly. So just open that notepad which is present in desktop and my file is ATI2C ADC. So I will copy this file into my project and just to open your editor window, click on File tab and select the option New. And just I'll paste my program and click on Save button to save your program in your project created drive. So my folder which is present in D drive, which is a learning room. Now give your file name as .c. This is the program file and this is the complete program to deal with I2C based ADC device. So within this program what I am doing, so I'll make sure the complete data frame. So I am implementing start condition with the device address followed by read/write bit. And then so you have to send your control byte to decide which, and I will expect acknowledgement from slave to master for every 1 byte of data transmission. And even after sending control byte, I will verify acknowledgement from slave. And then so after sending control byte, so now again I'll restart to change the mode to write to read. So this device address again you have to send to the slave and keep this process in read mode and verify acknowledgement from slave and do your read operation continuously. So this process, this is the complete data frame I am going to implement with this program between master and slave. And so this is the header file for use this microcontroller and interest H is the header file to use NOP inbuilt functions defined by interest header file. And this is my assumption: SCL and SDA connections which are connected with P2.0 and 2.1. So these are the two lines which are used for SDA and SCL communication, and these two indications I am using for right communication and wrong communication. So once communication is successful, I'll indicate green, and communication false, I'll indicate red. And this is the function which is defined to initiate the communication, which is start, and delay is the function for each clock cycle, and read is the function which I am using to read the data from ADC to master, and write is the function which is declared as with argument which is unsigned char. So this function sends the data from master to slave, and conversion is the function. This is used to convert the hexadecimal data which reads from ADC and to display equivalent form as ASCII characters in serial terminal. And check is the function to verify the acknowledgement every time between master and slave. And no acknowledgement is the function to terminate the communication from master to slave. And stop is the function which is terminates your communication. And bit variable C, which is defined as initially with the assignment logic 0. And these are the temporary variables I am using to show the result, and variables v11 and v15, and obviously so see the variables importance in the program one by one. And here main program starts, and these are the initial conditions of indicators. So both are off. And these are the steps to initialize the serial communication: SCON value as 50 and tmod value as 0x20, and baud rate is 9600, because the value whatever I am reading from ADC I am sending to serial terminal. And start the timer. These are serial communication initialization steps. And so this is the condition which is start to initiate I2C communication between master and slave. And just see the description of this function which is start. And what is start condition generally? While SCL is high, you have to make SDA low to high once. This SCL is high and SCL high to SDA high to low. So while SCL is high, make SDA high to low once. This is the start condition in I2C communication. And go back to main program, and this is the write. I am sending slave address from master to slave. So this is the data frame I am implementing one by one. So now this is a device address which is 90 along with write operation. So this is the function I am calling here. So just see the description of write function in this same program. So this is the write function. So this write function you have to send bit by bit from master to slave. and the 90 which is assigned with a variable which is val and which is assigned with v5, and this is a 1 byte value. You have to send bit by bit from master to slave. So SDA allows only single bit. So further I am doing logical bitwise AND operation with v5 with 0x80. So this 0x80, so your I2C communication allows the data from MSB to LSB. So I am doing logical bitwise AND operation with 80. So v5 is the original content which is passed from main program, and which is I am doing with logical bitwise AND operation with 80. So finally you will get only one binary bit based on original data binary bits. Now your SDA allows either 0 or 1, so which needs one clock cycle for every 1 bit operation. And always you have to keep your original data in MSB position by doing this left shift operation, and this process continues 8 times because in my original data I have 8 bits as an argument. So after completion of this, I am verifying acknowledgement from master to slave by moving SDA logic to C bit variable, and this SDA logic which will give acknowledgement from master to slave. So this acknowledgement verified by master, provided by slave, and which happens at 9th clock pulse. If acknowledgement is 1, then I am going to indicate a red LED, and if acknowledgement is successful, I will pass the next byte to this slave. So this will happens continuously, and this is the channel I am going to use from ADC device. This is 0x01, which means analog input channel 1, that means AIN1 from your PCF8591. So this control byte decides analog channel 1. After sending this control byte from master to slave, this is analog channel 1, and next I'll keep this continuous process in while loop, which is while of 1, and so once this will happens exactly, then I'll turn on green LED and I'll turn off red, and I'm shifting to read mode by doing restart, and this is the start condition. Again in data frame, just follow the data frame on top of the program, which is restart I am doing here, and I am shifting from write mode to read mode by making least significant bit, which is r/w bit, as 1. So once you are making that bit as 1, which will turn to read mode and call your read function. So what is this read function in this program? So this read function allows the data from slave to master, so that is bit by bit. So this is the process I am doing here. CH is the local variable, which is, so this variables stores the complete 8-bit information which comes from slave by doing this for loop. So this for loop which allows 8 clock cycles, and for each clock cycles I am going to save the logic of SDA, which is M. Based on M logic, I'll do certain operations on CH temporary variable. So once M bit logic is 1, I'll do OR operation with CH. If there is no 1, that means if SDA logic is 0, I'm not doing OR operation for your CH. Just I'm shifting this CH because the first bit which comes from slave to master, which is MSB. So I have to keep this data at MSB position after completion of this read operation function, and this function which will gives the complete data from slave to master, and I'll send this temporary variable for conversion purpose. And what is this conversion function within this? So this conversion function which will convert your data into, like, suppose 0x25. So this 25 is the hexadecimal value which is provided by read function, but this you have to display as a 2 as a character and 5 as an individual character. How to separate this 0x25 as two different characters? So this conversion function which is help us to do the ASCII conversion, so by dividing with 10. So now I can separate your 25 hexadecimal value as 2 and 5 by doing division operation and modulo operation. By doing division, I'll get 2 as a character in V13 variable, and in V14 variable I'll get quotient from this 25 divided by 10. So now 2 in this V13 and 5 in V14, and this 0x30 is the ASCII equivalent value for 0, and by V13 what it will holds now 2 or operation with 0x30. Now you will get 0x32, so which will displace as a 2 in your serial terminal by doing ASCII conversion. And these are the steps you have to follow for serial transmission. V13, and then verify your transmission with the help of TI bit. Once transmission is done, TI becomes 1, then I will come to the next step. So I will send the next character which is V14. So the two characters I will send from microcontroller to serial terminal by using these steps. So these are the steps for each line which will comes. So this is the final program to implement this complete data frame followed by I2C protocol. So first start device address in write mode and verify your acknowledgement and control byte and acknowledgement verification, and do the restart and device address in read mode and acknowledgement and read the data continuously in the while loop. So the same process I am doing in this main program. So this is serial communication initialization steps, and next is start condition and write operation in write mode and control byte value to choose the channel, and this is the continuous process I am reading the data from slave to master. So this while loop which will runs continuously. So just create hex file to verify the output with Proteus simulation by adding this file to this source group. So add the source group to check errors and warnings in this program, and go for project tab and choose build target option. Now I don't have any errors and warnings in this program, and create hex file by choosing the option 592. This is the frequency which allows serial communication, and highlight this use on chip ROM and click on output tab and select create hex file. Click on OK and build once. Now it will create hex file from your keil microvision, and minimize this and open your Proteus tool, which is help us to see the output of PCF8591 with 8051 master, and choose your components from this library by click on P symbol. Choose the microcontroller and choose your serial ADC which is PCF8591. This is PCF8591 is the device, and deal with one temperature sensor which is LM35 which is available on Proteus, and take one pot which is variable resistor, which is used to set the reference voltage, and then you need to connect one serial terminal which is available on instruments mode. Choose the microcontroller and select ADC to interface with microcontroller. And now connect your LM35 sensor prepare your circuit in a clear format, and now choose the LM35, and this LM35 has 3 terminals. So one terminal, first pin you have to connect with VCC. By choosing terminals mode, you can connect VCC, and third pin is the ground, and the second pin of LM35 sensor you can connect to analog input 1, and these SCL and SDA, which are connected to as per program, decide your hardware connections. So SCL and SDA. SCL is connected to P2.0. Just make sure your hardware connections, and P2.1 is connected with SDA, and decide your 3 hardware address lines as ground. So you already set the value as 90. So to this 3 hardware address lines, and make sure your external pin, which is you have to disable by connecting to VCC, and set your reference voltage by using pot. So this pot allows, so one terminal you have to connect with VCC, and other terminal you have to connect with ground, and variator pin you have to connect with reference. And this is the hardware connection, and to see the temperature value you have to connect one serial terminal. So this virtual terminal, which is help us to see the output, what temperature which is. Just connect do the cross connection with this, and then let's link your hex file with this. So my hex file, which is present in D drive, from my computer D drive, and choose my hex file from a specific folder, and give the same clock frequency as 11.0592 MHz. So this allows temperature with the value so just adjust your reference voltage based on that. So you will get accurate output from your temperature sensor. So once you are varying your temperature from this, you will find some variations in this. Okay, just change your temperature sensor, you'll get variations with the output. So these values are very genuine with your output. This is the way you can test your serial ADC with the master and slave concept. Thanks for watching.